Welcome. In this video, we're going to use a table of values to sketch this curve defined using an angle and a radius, so polar coordinates. Let's begin by creating a table of values. So please pause your video and copy down a table of values in your own notes. It looks similar to this one. So angle, and actually up here I'm going to write r equals 2 cosine of that angle. So please create your own version of this table. All right, so you should have paused your video and created your own version of this table. So let's begin with 0. When theta equals 0, what does r equal? The radius is going to equal 2 times cosine of 0. So 2 times 1, which is just 2. Now, I don't have to do this 1, this 2, and so on. I can make these a little larger. And I'm going to do that. So I'm going to say this is a radius of 1, this is r equals 2, this is r equals 3 here. So r equals 3 is here. And then to keep this out of our way, I'm actually going to write this here. I'm going to write r equals 1, r equals 2, and r equals 3. There we are. I like keeping it there a little bit better. So in essence, I'm saying that this is a circle with a radius of 1/2. This is a circle with a radius of 1. This is a circle with a radius of 3/2 of 2, and so on. Okay, so at an angle of 0, which I just realized I have mislabeled on my own document here. I have it mislabeled as pi over 12. So let's quickly fix that. Yours and your own notes should be correct. There we are. So now here at this angle of 0 that is along the positive x-axis, I want to go out to where the radius is equal to 2. So that would be right there. So when theta is equal to pi over 3, our radius is equal to 2 times cosine of pi over 3. So 2 times 1/2, which is just 1. So let's look for pi over 3 and hope I didn't mislabel it this time. I did not. It is here in its correct location. It's not, say, over here. That would not be great. Anywho, it's here, and I want to go out to a radius of 1, so right here. Okay. And then I'm going to sketch one more point, then I'm going to start connecting these dots for you. So next, let's look at pi over 2. R is equal to 2 times cosine of pi over 2. So that's 2 times 0, which is 0. So at an angle of pi over 2 here, which, unfortunately is also mislabeled as pi over 12. I think those of you watching can tell which number I started with and copy paste it over and over again. So let me fix it on mine. There we are, pi over 2. So at an angle of pi over 2 here vertically, our radius is 0, so our point should be here back at the origin. And now I'm going to trace this out. Okay, so as you can see here, we started with an angle of 0 and got a radius of 2. So we went all the way out to 2. Then we went to an angle of pi over 3, which is along this line, and got a radius of 1. So we drew a point at 1. So we're traveling in this direction here. And then finally, we looked at an angle of pi over 2, which is up here vertically. This angle is pi over 2. And we got a radius of 0. So let's keep going now. 2 pi over 3. So r is equal to 2 times cosine of 2 pi over 3. That's 2 times negative 1/2. That equals negative 1. So let's find that angle here. 2 pi over 3 is here. And this would be a radius of 1 here. So r equals negative 1 is here on the opposite side. So this is r equals negative 1. And this is where you want to put your point, right here. Okay, and let's continue connecting this now. And now let's do the last point. That is an angle of pi. So r equals 2 times cosine of pi. So that's 2 times negative 1, which is negative 2. So at an angle of pi, which is this angle here, we would stop At the negative y-axis, we want a radius of -2. Well, here's 1, here's 2. This is r equals 2. So r equals -2 is here on the opposite side. So your point goes here, is where that point goes. And look, that is where we started. So I'll just color in half of this point. There we go. So there we are. This looks like a circle whose center is shifted off 1 unit to the right. Now, I have a quick question for you. The reason we stopped here at pi was because I told you to stop at pi. So my question, I guess, is what if we don't stop at pi? So let's try one more. Let's try 4 pi over 3. So then r is equal to 2 times cosine of 4 pi over 3. So that is 2 times -1/2. Again, that's -1. So here is 4 pi over 3. So again, we're assuming they're traveling in this direction, and there's the angle of 4 pi over 3. So this would be the terminal side. And we want a radius of -1. Here is r equals 1 in this case. So r equals -1 would be here. So you notice you'd be here at pi. Let me make that clear. This is r, not r, excuse me. Theta equals pi. And then you can continue moving in this direction. So we'd continue moving in this direction and so on. And then you'd end up right here. So this would be theta equals 4 pi over 3. So the idea is, if you don't restrict your angle, you're just going to trace this circle over and over again. So if you started at theta equals pi, you could go all the way around to theta equals 2 pi and get another circle. All right, well, I hope you found this video helpful.